Hi, welcome to the statics tutorials. So in this problem we have a particle here at E with the mass of m that's suspended by this cable system. Each cable can only support a maximum of 1,000 newtons, so we want to find out what the largest mass m can be supported by the system. So let's draw our free body diagram. So we'll have our weight here at E, which would just be the mass times gravity. We'll have the force B to D. And then we'll have the force B to C. And then we'll have our force B to A. And now we can go ahead and start solving it. It looks like B to D is just going in the Y direction. Looks like B to C is going in the X direction. The weight is going straight down, so we don't have to break any of those up, but we do need to find the components for this force going from B to A because it's traveling in X, Y, and Z. So let's start off with the position vector that goes from B to A. So our position vector is going to go from B over here to A. So we're going to go minus 3 meters in I. We're going to go minus 4 meters in J. And then we're going to go 3.5 meters directly up. So there's our position vector. We need to find its magnitude so we can divide through by it. And we get 6.103 meters for that magnitude. Now we can go ahead and get this force vector from B to A. So we can say force vector B to A is equal to magnitude of that force vector times RBA divided by the magnitude of RBA. So we'll take each of the components here, including the positive or negative sign, and divide them by the 6.103. So it'll be 3 divided by 6.103, that'll be our new I component. 4 divided by 6.103, that'll be our J component, and so forth. So this will give us our magnitude, FBA, times, after we do all that arithmetic, minus 0.4915 I minus 0.6554 J plus 0.5735 K. All right. So now let's go ahead and start with our sum of forces. So let's start with sum of forces in the Z. So we'll have our Z component out of this. It'll be FBA times that coefficient. And let's look at our other forces. So FBD only goes in the XY plane, so it doesn't have a Z component. And FBC only goes in the XY plane, so it doesn't have a Z component. That just leaves us with the weight as the only other force that has a Z component. Now we can get an equation for FBA in terms of M. We'll do this by sending the 9.81 times m to the other side of the equation, or adding m times 9.81 to both sides, and then dividing through by this coefficient of 0.5735. Now we can do the other two components. Let's do sum of forces in X. Pick the X component out here. And FBC, let's see if it has an X component. FBC looks like the whole thing goes in the positive X direction. Let's look at FBD. Looks like FBD goes in the positive Y direction, so it doesn't show up in this equation. So we'll rearrange. By adding the 0.4915 FBA to both sides. Now we'll just go ahead and make this substitution. So let me just circle what we're doing. So we're going to take this 17.11 M and substitute it in here for FBA. So we'll take our 17.11 times M, multiply that by the 0.4915, and that'll give us a coefficient of 8.407 times M. Now let's do our sum of forces in the Y direction. So we'll have our Y component here. And then it looks like FBD here goes in the positive Y direction. And again, we'll take this substitution that FBA is 17.11 M, bring that in here. And that gives us that FBD is equal to 11.21 times M. Now, in looking at these, we have to figure out which one of these forces is the largest. So for any value of M, this one's going to be 11 times M, this one's going to be 8.4 times M, this one's going to be 17 times M. The 17 times M is going to be your largest value. So take your largest value and set it to be your maximum. That way, when this one's at 1,000, these two will then be less than 1,000. If you take one of your smaller values and you assigned it to be 1,000, this one would exceed 1,000, which means your cable would either break or would be exceeding design capacity. So we'll say that FBA is then equal to 1,000 newtons. That gives us an equation that we can solve for M. So we'll get M is equal to 58.4 kilograms, and that's just taking the 1,000 and dividing by the 17.11. You can go through as an exercise, and once you calculate FBA as being 1,000, plug it in here, and once you calculate the M as being the 58.4, plug it in here, and you'll see that both of these two are less than 1,000, and that's perfectly acceptable for them to be less than 1,000 as long as one of them is at the max, is at 1,000. Thanks for watching.